A little introduction about myself and the company and so on. My company is called SPAN. It was founded together with Sandra Manninger in Vienna in 2003. And in the meantime, we were able to expand the office from Vienna to Shanghai and to Detroit. In this lecture, I will introduce you to some of the obsessions, ideas, fascinations that Sandra and I share in our work and that I would like to share with you. So the whole lecture is called Machine Hallucinations, and I will go into detail in the lecture about why it's called machine hallucinations and how machines can actually hallucinate. Yeah? And in general, I consider this a post-digital conversation. This is a very contested term. I don't think there's a general definition yet of what actually post-digital means. The one thing that I can say about it is that it has a lot to do with the crisis 2008 and the change of digital architecture after that crisis. And the interesting point of Mario Carpo's presentation of his book, The Digital Turn, and the question of what happens after that. But first of all, I would like to talk a little bit about ontologies of form. I would say I'm a formalist. I'm not ashamed to say that I'm a formalist. Yeah? And form for me was always very important because it is an agent of culture. It represents culture very importantly. It defines us very specifically in our endeavor as humans to create art and, of course, architecture. So ontologies of form discuss where does form come from? Why does form emerge? What is important about form? Which rule sets are applied to it? I'm not showing this here because I'm today in Prague. I show this in every lecture I do wherever I go in the world, explaining not only my fascination for form, but also where do I come from. This is the rose windows of St. Stephen's in Vienna. I passed by this window every single day on my way to school, and I never saw it. Yeah? It came much, much later that I started to understand that all the things that I was seeing in Vienna on a daily basis, going to school, influenced me profoundly as an architect. The ideas of how geometry shapes form, how it emerges in specific ideas of expression. Yeah? This is the pulpit of St. Stephen's, where this idea of translating natural phenomena into very specific geometrical conditions and how to translate those geometrical conditions into material is something that for sure shaped my ways of thinking about architecture. Or piles of strange things. Yeah? This is a pile of strange things, one on top of the other. Yeah? This Baroque masterpiece of the Pestsäule in Vienna, which is a very strange sculpture if you think about it. It's this kind of weird clouds and putties and crosses and saints and all mixed up in this really strange cloud. Yeah? So on the one side, you have this desire in Vienna, obviously, for the dramatic, for the spectacular, for something that has a lot of expression. But at the same time, you have in Vienna also people like this, yeah? Otto Wagner. I describe people like Otto Wagner and Adolf Loos as proto-modernists. People who very early on had an idea about modern architecture and how it should be expressed in our contemporary age. If you are in this sort of tension as an architect growing up in Vienna between these two poles, on the one side this lush Baroque tradition, these very expressive Gothic ideas, and at the same time you have the pressure from the other side, the reduced, the modern, the clean, yeah? It's almost a schizophrenia. You need to find a way how to navigate between those ideas. In this line of ideas that I like to show when I do these lectures is also people like Hans Hollein, who were actually able to translate this friction, this tension between the Baroque desire and the modern idea into very specific methods of expression of architecture. I was also in the lucky situation that he was my teacher, so I probably got somehow infected also around these ideas. Although I think I found my own language and voice in that sort of idea. So, but now actually for the main act. Yeah? So this was all like, yeah, interesting stuff and so on and blah, but basically the lecture is called Machine Hallucinations. And we need to, that's actually the main reason why I'm here today, is to talk about artificial intelligence and architecture. to do this, first thing we're going to do is define it. What is architecture? What is artificial intelligence? Yeah? There is actually specific definitions about it, how you define artificial intelligence. There's 3 specific aspects that it has to fulfill. Yeah? One is intentionality. So there must be an intentionality behind that whole approach. Yeah? Otherwise, it doesn't make any sense to use it. Now, the next one is a bit more complicated. It has to have intelligence. The problem is that there's like 15 different definitions of what intelligence actually is. There is, of course, organic intelligence. That's what we have as humans. But there is also machine intelligence that works a little bit more different. I don't want to go through the whole reading the definition. This would take a bit long. But the third aspect is also pretty obvious, I think, which is adaptability. That's definitely something that defines intelligence, is that you are able to adapt to changing conditions. And that's what we humans can do profoundly well. We have proven that over the thousands of years, how we can adapt to a variety of conditions, no matter if it's weather or other problems, food shortages, and so on. Now, if you take all these 3, that's going to be the basis for the conversation of what actually artificial intelligence is. But there is another question. Why use an AI? What's the reason to use an AI? Yeah? It's not using the AI for the sake of using an AI. There must be an intentionality again for that. The reason to do that is that it's much better to teach a machine how to learn instead of teaching it what to do. Yeah? What it means is, if you have a robot arm, yeah, and you have to program every single time, for example, when it's welding a car, yeah, this can be a repetitive process, right? But what happens if the same robot is supposed to not build 1 model of car, but 4 different ones? Yeah? Yes, of course, you could program every single time that process again into the robot. Or you use an AI where the robot understands that if I'm welding this point on this car, then I have to weld this point on the other one. So there's this idea of understanding what the job is and how to fulfill that job. And of course, that saves time and energy and so on and so forth. So there's very specific good reasons to do that. You have to understand also that there's 2 specific directions of AI research going on these days. One is about generalized AI. So generalized AI would mean an AI that can do a lot of things at the same time. Think about the robot in Ex Machina or Data in Star Trek. Yeah? He can talk, he can calculate, he can walk around, and so on. All these things at the same time. Now, this is actually profoundly difficult. Yeah? What we are doing as humans is for robots these days still almost impossible. Yeah? For example, if I'm talking to you, at the same time, my heart is pumping blood, my balance is trying to get balanced so that I not fall over, I'm digesting food. Yeah, all of these things are actually complex processes that are all controlled by our brain at the same time. So we don't have to think about that. I don't have to think that my heart has to pump or that I have to draw in air and out, right? For an AI, this would be profoundly difficult. Yeah? The same with, the agents in the Matrix are similar artificial intelligence that can do several things at the same time. So let me tell you a secret here. No one in AI these days says this is possible. Everyone says, don't do that. What the people are doing today are so-called applied AIs. AIs that do one thing, but this thing they do really well. Yeah? So instead of trying to make a robot that is as human as possible, which is kind of childish, to be honest, yeah, they're actually trying to create machines that help us do things better or easier. Let me give you an example. Every one of us writes numbers differently, a little bit by hand, a little bit here, a little bit there, right? When you write a check today, no human is looking into these checks these days. It's all machines that are trying to understand which numbers did you write. And that's an AI. How this works is like this. This is a good example of an applied AI. This is a neural network that learns how numbers look like. And how this works is that at the very first row here, you give it thousands of images of a 5 in this case. So from different people, written by different people. And you feed in a couple of thousand images of that. Yeah? So it goes into the system, and then a human trains the AI to understand this is a 5, this is a 3, this is a 2, this is an 8. This training process has to go, it can be in one go, like in this case, where it then goes into the incriminator and the bias filter, and then at the end, the AI understands it's a 5. Yeah? The more images it gets, the more images go into the system, the more precise this prediction will be, or this definition will be. So by today, because those systems are in banks all over the world, we're not talking about 2,000-3,000 examples of a 5. We're talking about millions of examples. So that's why AIs today can absolutely say, this is an 8, this is a 1. Yeah? It works. Okay. Another aspect which I'm highly interested into is the idea of the post-human perception of the world. AIs see the world differently than we do. Yeah? And I think it's really interesting that we're starting to share specific agencies in our world with other proponents. The humanist idea of the human being on the top of a pyramid and everything goes below that, culturally, intellectually speaking, I think we're saying goodbye to this idea. AIs see the world like this. This is basically how a car perceives the world, an automated car. Yeah? So how we see the world is very different to what AIs are doing. They actually differentiate space by distance and temperature and trying to make the biggest possible contrast to understand where things are. My dear friends at Michigan Robotics, that's what they do the whole day. They train AIs to understand the world, yeah? How to see the world. So that's why machine vision is so important in this case. Now for the whole title of the lecture. You heard a couple of things now. Machine hallucinations is a title that I didn't invent. Yeah? Or let me put it this way. I put together certain things that I heard somewhere else. I'd rather put it this way. So when I was for the first time talking to these people at robotics about how to use their progress in machine vision in architecture design, they started talking about dreaming and hallucinating, and all. We started to use this terminology, and I was very surprised about it. Why are you talking about hallucinations? Why are you talking about dreaming? What I found very surprising in the case of robotics, they told me they borrowed those terms from neuroscience. So it's a very interesting connection here that hallucination, psychedelic dreaming, all these little things are well researched enough that computer scientists can replicate this behavior through writing neural networks. And that's the way how they start seeing things. Yeah? You remember that I mentioned this database of numbers, yeah? 5s and 8s and 3s. You can do the same thing with more complex information. So this is an example from some of my thesis students. They created these databases of basic architectural features. Arches, columns, doors, ceilings, stairs, and so on. And created for every one of those classes one database of images that they were automatically downloading from the internet. Yeah? Every one of those databases has at least 1,000 images. More is better. Then they created a neural network that was able to pick up those images and apply them to any other architectural problem. But then they came up with something which I thought was really brilliant. Instead of using images that they found on the internet, they started to use their own renderings. And that basically means they were starting to train an AI how to apply their own sensibility on any given form. I thought that's brilliant. So basically what they did is this here. On the left, you see one of these original images, original renderings, and on the right, you see a neural network that is basically hallucinating this formal language to another building. Here we are again with the style transfer. Style transferring is something that people have been using very loosely already for a couple of years, where you take any sort of image and you dream dogs or birds or whatever on top of it. But we were really trying to understand how we can use that more creatively in an architectural context. So basically what you do is you have a style image and you have a target image. So the style image is what you're going to use to hallucinate on top of the target image. And I have here an example from art. Yeah? This piece of art by Paris-based art collective Obvious, yeah, was sold last year for $432,000 at Christie's, and is supposedly the first artwork ever done by an artificial intelligence. It's a good selling point. I guess that sounds really great. But basically what it is, it's a style transfer, like we were discussing before. So they actually created a database of Dutch master painters, and then based on that database, they were able to generate this here. What is more important here is not so much if the artwork is good or beautiful. That's not the point here. What is more important to me here is it is evidence that artificial intelligence is getting taken seriously enough that is considered an artist that generated something that is worth money. Yeah? So that again shows that we're starting to share agency in this playing field of creativity and art. Yeah? And for architecture, I think it's really funny that the term style, I mentioned style transfer before, is actually returning into the architectural conversation via the use of advanced technologies. So an idea like style from Semper can be basically reread in the context of artificial intelligence as another opportunity to create a contribution to architectural discourse. Yeah? Again, you remember that I said before already, instead of us trying to discuss too much the architecture through its technological means in digital design, rather discussing it through its value as a contribution to discipline and discourse. So how do we use these ideas now in architecture? Let me give you a small example here of a style transfer in architecture. At the moment, this is more like an inspirational tool than really a tool that defines a specific project, but we actually try to use it as a three-dimensional representation. At our design for the Austrian Pavilion for the Expo 2020, we didn't win it, but we were close. But nonetheless, the idea was really to take all these sort of Baroque ceilings from Vienna and create a style transfer to a modern building. So you see there's very specific modern features here, like this, the floor is very modern, there's like very specific straight lines that define it as a modern interpretation, but then it has that profoundly Baroque ceiling, or these very articulated chapels to exhibit some things. Now, what I'm showing you here is again, the next step in the research for the use of AI in architecture, which is how do you translate those things into 3D? There is this group of scientists, Hirohiro Kato, Yoshitaka Ushiko, Tatsuda Harade from the University of Tokyo, who developed a three-dimensional style transfer technique, which we tried to apply, but the more we went into the nitty-gritty of the algorithm, the more we figured out that it's not really working that well. So right now we are developing a variety of different techniques, how to extract three-dimensional information from images in order to create a spatial condition. It's again some student work from my studios. It's one of my favorite ones. This is a beautiful style transfer here that led to things like this here, or really strange sections like this here. And talking about strange can be good. Yeah, I like strange. The strange or weird or different or ugly are categories of aesthetical expressions that we might just not understand correctly. So maybe it's not ugly, we're just not used to it. Yeah? So things just change over time. So using all these techniques, we were actually able to build, or we are currently building the first building project based on these AI techniques. We went through a lot of variations with these projects because sometimes these neural networks give you results that are completely useless, like this one here, yeah? Or this one here. So it took several attempts to get to one result that was useful, which is this one. And this is the basis now for the rest of the project. And we're generating some colorful boulders for the project too, playing around with coloration. Currently, this is the state where the construction site is in. Now, this was basically some ideas about what we call imaginary plans, where we actually also use two-dimensional information to do that. But our most recent research is going back into the scale of the city, talking about the imaginary city. So basically picking up on ideas about cities and landscapes and how those can be fused by using neural networks. And I love these very strange plans that we get out of it, where you definitely can recognize there is this sort of urban texture emerging out of the different results. And for me, what is very, very interesting is all the things are basically unpredictable. You give them information, and then you get a result out of it, and very often it's actually the task of the human to interpret these results again, understanding, is this useful or is this not useful? Can I do something with it or can't? And I think that might be just because this technology is so new that we don't have it completely under control yet. But again, to come back to my argument, it's rather about discussing how does it fit in an entire context of the history of urban design rather than, how did I do it technically? Because we had so much fun with it, at the very end of this research, we did the following. We designed basically an idea of how to do cities on the moon. Yeah? I think that's a good way to end this lecture by saying basically that these hallucinations are what's going to define, at least in our case, our work for the next couple of years probably. We see a lot of potential in this approach. There's still a lot of work to be done there. You see how abstract still these results are, but they're highly inspiring in terms of seeing that we can push this forward no matter in which scale. So this approach can be applied to industrial design as much as can be applied to building, as much as it can be applied to the moon. Yeah? A little bit about writing. I enjoy writing, so there's a couple of books out there if you want to have a closer look into what we do. I can highly recommend the AD that we did a couple of years ago. Or you can also, for free, go to RMIT and read also my PhD, which is called Autonomous Tectonics, and basically summarizes a lot of the things I was talking about today in a very consistent and complete way. And with this, I would like to say thank you very much.